We're sitting in a 2006 Chevy Silverado 2500 with a check engine light on. We pulled codes and we're getting a P0446. So let's check it out. Pulling up the data PIDs, and you can see our fuel tank pressure sensor is at 4.8 and it should be roughly around 1.5. I took the gas cap off. We have no change in the fuel tank pressure sensor voltage. If there was a blockage in the system, I would suspect once taking the cap off, that would relieve any pressure or any vacuum in the system, and this would change back to atmospheric pressure at 1.5 volts. We're not seeing that, so now I think our fuel tank pressure sensor itself may be faulty. Okay, so I went under the vehicle. You can't really get to the fuel tank pressure sensor. It's right on top. You have to lower the tank, so we're not equipped for that at the moment. I just wanted to check the vent solenoid. It's on the back of the tank up here. I disconnected the wiring. And what's interesting, let me plug in my test light again. It's just a simple solenoid, so it only needs power, ground to actuate. There's the test light on my scan tool. Let me go ahead and turn it on. I'll wait for that to activate. All right, it says it's on, but we're not getting anything. So that's interesting. You can see here, maybe it says it's on, but no juice. So pull this out and see what are we missing. Test light hooked up to ground, and we have light. So we have a power going back here. We're missing our ground. I'm going to look at a wiring diagram because it's possible that the ground to the vent solenoid and the ground to the fuel tank pressure sensor may be the same. But let me check. Before I slide myself from underneath the vehicle, I just want to check, will this vent solenoid kick on if it had the ground that it needed? So with my power probe, I'm going to just give it a ground. And it does turn on. I'm not sure if you heard that click or not, but it does turn on. So we're missing this ground. Let's go find it. So this is what I was afraid of. So that power that we have is power at all times. The engine computer actually controls the ground side of the vent solenoid. Also, if you look, this is the fuel tank pressure sensor. It is also controlled by the engine computer, all of it. But notice C152, they share a common connector. Interesting. So it's very possible that we have a connector issue. Hopefully that's what it is, but our ground should be coming from the PCM. So let's look under the hood. Let's try to find this C152 and in the engine computer to see which one is easiest to get to. Because if we're grounding from here, but it's not getting to there, then we have an issue in between. But we want to find out what's the easiest location to get to proceed. Okay, I'm under the hood. The connectors look like they're under the fuse box. I don't know which one it is. According to the diagram, it looks like maybe this one. Either way, I guess I can just look at all the connectors that are under here. To get the fuse box out, it has a case like this over the top of it, and then there's a little support bracket that goes from here to there. They're just two 13mm on that side, two 13 on that side, and that bracket comes out. Then this can just unclip and it pops off, and then the fuse box top here, or the fuse panel, there's little tabs on this side, tab on that side, and then this right here, and that lifts up. And then you can get underneath it. So back at the diagram, we're looking for a white wire. So white goes in, white comes out, at least according to this diagram. So let's find the connector with the white wire. I believe there's only two that have a white wire. So we'll disconnect those and just get a good look at what the connector looks like. Okay, I couldn't figure out which one was which. So what I did is I just unplugged the ones I thought, this one or this one. Looked at the connectors, everything looks nice and clean, looks good, but then I just started disconnecting everything just to check every connector, just to be sure, because I don't know if I'm looking at the right one or not. So I think my next step is to find the engine computer, get the wire coming directly out of the engine computer. So the engine computer is right here if you want to tackle that. I still think I'm going to do something else first. There's a lot of wires. I already have the diagram open for this, so I'm going to just make sure that one of these white wires is it or not. And how I'm going to do that is a simple continuity test. So I have the vent solenoid unplugged. On the white wire, I have a lead coming all the way from that white wire to my multimeter. Multimeter's on ohms. I have this unplugged. Now I want, which side do I choose? This side or the other receiver? Well, I want the one that goes into the harness that goes to the back of the vehicle. So that's this side of the harness. White wire here, plugged into the front. So now, with my other end of the ohm reader, put this in, and if it's the same wire, then I should be reading a very low ohms, and I am. 0.4, 0.3, very low ohmage. That means that this wire that I'm connected to here and the white wire back at the vent solenoid are the same wire. Now I'll prove the concept by unplugging this other white wire, and we should get an open in the system. So now I'm hooked up to this white wire here in the front, just the same as I did on the other one. And so the same thing, if this wire and the back wire were the same, we'd be reading an ohmage, but we're not. It's an OL, or open. So they are not the same wire. So for you guys, what that means is that this black one is not the one we need. It's this one in the front, this white connector wrapped in purple. That white wire is the wire we need. Now we already just did a continuity test. So that tells us that this wire all the way back is good. We haven't loaded it, so why don't we just do that? Let's load this wire with some voltage, and we should be reading voltage back there. In fact, let's just give it a ground, and our light bulb should light up, or a vent solenoid if we have it plugged back in. Okay, so we are hooked up to that white wire. We're going through a 5 amp fuse just for safety, and we're going to give it a ground. Now I have the test light in the back. Crawling on the vehicle, and you can see that we are lit up. So again, that proves that we're on the right wire. Just now back to our connector. This is the computer side. We want that fattest one on the top right. So we're going to hook up to that. And just thinking about it too, this is another way to check the fuel tank pressure sensor, because this is the same plug. You just need to find the wires available for it, and this is where you can check it instead of dropping the tank or lowering the tank to get to those connectors back there. A lot easier up here. Let me hook up my stuff to this big fat one and see if we got a ground coming from the computer. Okay, so I'm hooked into the front where I need to be, battery positive for my test light. So if we get a ground coming from the engine computer, test light will light up. So let's go ahead, turn it on. Let it turn on. Takes a minute. There we go. And we're getting nothing. So now we do need to go to the engine computer, find that wire, and see if it's coming out of the engine computer or if there's some mess up between that connector on the computer and this connector here. Just to refresh our memory, we're looking for pin 45, which is a white wire coming from the engine computer. Pulled the computer off, if it'll focus. Looks immaculate in there. All the weather sealing and all the pins look really good. So that's the computer there. The connectors are the same. They look really good. So on this green connector, you see this white wire here. Those little numbers inside, those are pin numbers. So great. So that white is pin 45. To confirm, trying to do this one-handed. I should have brought my phone stand. Where did I put? Oh, just to confirm, we can run the old continuity again. So that one there is our white wire and 0.2 ohms. Unfortunately, that also means that this wire integrity from here to that connector seem to be intact. Now let's see if it can carry a load. I'll hook up a little power to this. We should get power on the other side to light up a test light. So I have it front probed. Just to let you know, I am using a special kit for electrical diagnostics. I got mine off AES Wave. Not a sponsor, but I am a lover of this. It lets me get the right pin fitments, so I'm not stretching anything out or forcing anything in. And it comes with so many adapters. Anyway, I just want to let you know I'm not just jamming stuff in, and you shouldn't just jam stuff in either. Sometimes you can use like safety pins or things like that. Can be small enough to get in to some of these pins. But anyway, my 45 is actually hooked up to ground. So I got my test light on the positive. So if that wire is intact enough to carry a current, it'll light up my bulb. And there we go. So we can plug it back in, back probe our wire just to confirm that we're not getting our ground from the engine computer. But at this point, all our wires going to the computer have proven to be good. So deductive reasoning would say, well, the computer is just not grounding our circuit for us. All right, this is one last test I'm going to do. So I'm not going to back probe. I can't get this connector off, this little shield off very easily, so I'm not going to keep working on it. I could pierce the wire here, but I don't feel like I really need to. So this is my last test. I got this plugged back in. I'm feeding a ground to our pin 45. If the circuit integrity from this all the way to this connector, through this connector, and back to the vent solenoid is good, then the light should be lighting up. Under the vehicle, there we go. We are lit, nice and bright. So our wire integrity from the vent solenoid all the way to the engine computer's connector on the other side of the connector, not the back side, but the front side, is all good. To me is enough proof to condemn the computer that it's not giving it the ground that it should. Next step, before we condemn the computer 100%, is to do a power and ground check to the computer to make sure that the module itself is getting everything it needs to function. Before we button things up, I'm going to check just one more thing. The fuel pressure sensor. So this gray wire on the back of this connector, just back probing. That gray wire is our 5-volt reference. Hooked up to our voltmeter. Give it a ground. There's our 5-volt reference coming from the engine computer. Sweet. So over one is our green wire. That'll be our return. So according to the scan tool, it was spitting back most of our voltage back at us. And 4.9 volts, so that's right. Alright, and then we'll check our low reference, which is pretty much the same thing as the ground. So on that same connector, we're hooked to the black wire to a ground. You'll see 89 millivolts. And if we put it to the positive, you should see battery voltage. And 11.86. So pretty close. So I would say our circuit is fine for the fuel tank pressure sensor, but the fuel tank pressure sensor itself is not reading correctly. Well, there you go. This did not turn out the way I was expecting. When I saw the fuel tank pressure sensor, I thought for sure that's what it was. It's supposed to be around 1.5, 1.4 to 1.6-ish, generally in there. With the gas cap off, that should be atmospheric pressure. It's reading 4.8, saying that the system is over pressurized. So I thought, well, there you go. We got a fuel tank pressure sensor that's not reading correctly. The engine computer interprets that as a blockage in the system or the vent solenoid not actuating because that pressure never drops down when the vent is open. So it thinks, hey, we got a blockage, code P0446. But that P0446 doesn't always mean that there is a blockage, doesn't always mean that there is an issue with the vent solenoid. So running through some checks, found out that the vent solenoid wasn't getting the ground that it needed to turn on. Interesting. Traced it back, engine computer is not providing that ground. Now, we also did some checks on the fuel pressure sensor itself, or at least the signals up front, the 5-volt reference, the low reference, and the signal wire, all were reading within specs. So I still suspect that the back fuel tank pressure sensor is faulty. What I don't know is, would a faulty fuel tank pressure sensor prevent the engine computer from turning on the vent solenoid? I don't know. But these are the two things that I do know. Needs a fuel tank pressure sensor, and the engine computer is not providing a ground for the vent solenoid. Depending on what the customer wants to do, I may have a follow-up video, I may not, just depending on how things go in the future. But if there is any takeaways from this, it's to diagnose, to look at the circuit, look at the system, run some checks, because I could have thrown a fuel tank pressure sensor in here and said, well, that's all you need. But maybe it's not. See, at least the customer now is informed that you may have more than one issue going on. That gets their mind geared for future repairs if needed. It could be that the fuel tank pressure sensor is all that it takes. And in that case, that would be wonderful, but it may not be. So running through the checks, running through things before replacing components. Because another thing, I could have replaced the vent solenoid or the vent valve solenoid because I hit the on button on my scan tool and it never came on. So I could have said, oh, well, there you go. That's your problem. But it may not be. We actually turned it on manually. Put a little power to the solenoid and it actually actuated. So the vent solenoid is not bad. So just interesting stuff. Just running through a process of checks and deductive reasoning and coming to a sound conclusion. Just a quick tip on this particular vehicle. If you are replacing the fuel tank pressure sensor, you do not have to drop the tank. The manual says drop it. You don't. See where the filler neck comes in? Right there. You can. Let me go in a little further. Where that filler neck is, you could put your hand up in between there, and to the right of that filler neck is where everything is. That's where the fuel pump is, and that's where the fuel tank pressure sensor is, right back in there. So you can actually get your hands in there without dropping anything. Now you may, depending on how girthy your hands and arms are, you may have to lower the front of the tank just a little, but I didn't have to. Just getting my wee little hands up and in there, I was able to pull the plug and pull out the sensor, pop in the new one, plug it back in. All right, new fuel tank pressure sensor is in. Let's take a look at our readings. It's communicating right now. I'm looking at the fuel tank pressure sensor, and the gas cap is off. And there you go. 1.43 volts. That is right within our range. And now you can see our pressure is 0.63 millimeters of mercury. So that's atmospheric, right where we need to be. So now, let me show you something else that's pretty interesting. Evap vent solenoid, let me turn it on. This will just be a listen test. Now listen to it. So we are working. Now we can do an engine running test. Purge seal. We're going to want some PIDs. Fuel tank pressure. So as we increase our purge, close the vent, that'll create a vacuum in the system. The vacuum is coming from the intake manifold. You should see our volts go up. And there we go. And you can hear the engine change its idle as well. Well, there you go. I would say this car is fixed. Kind of an interesting case that a faulty fuel tank pressure sensor would also cause the engine computer to not turn on the vent solenoid. I want to throw this in here real quick. Why would the engine computer prevent the vent solenoid from turning on when it had a faulty reading from the fuel tank pressure sensor? Well, it stems from, what is the vent solenoid for? For preventing the fuel tank to be over pressurized or over vacuumized. With that in mind, the vent solenoid, how it works is when it's off, it's normally open, allowing the fuel tank to vent if it's pressurized or bring in atmosphere if it's in a vacuum. Like when the fuel tank is heating up, it expands. When it's cooling off at night, it contracts. So it needs to be able to stay open when the vehicle's off. When you turn the vent solenoid on, now it closes the system. The system no longer has the ability to vent. So the engine computer says, whoa, our readings are off, we need to vent. So it's a fail-safe. The engine computer said, we do not want this closed. We want it to stay open. If we close it, who knows, catastrophic, tank blows up, or collapses on itself and apocalypse and the world ends. So it prevents the engine computer from closing the vent solenoid or turning it on. Hopefully in this video you saw some ways of diagnosing an electrical system, some scan tool PIDs and active data that you can utilize in trying to pinpoint an Evap code like a P0446, and some deductive reasoning on our reading from the fuel tank pressure sensor. Instead of thinking there was a blockage like the code suggests, we saw that pressure sensor reading and thought, oh, well, right away, it must be something related to the pressure sensor, giving the computer a false reading. So the computer came up with a false idea of what was actually happening. Also, replacing, at least on this particular vehicle, replacing the fuel tank pressure sensor did not require lowering the tank at all. The manual information was a little misleading. It said it was in the back of the tank. On this vehicle, it was not in the back of the tank. I had to use a little scope camera to kind of scan the top of the tank until I found it more towards the front of the tank. And then I was able to get my hand in there, kind of by the filler neck area, get my hand back in there and pull it out. All right, thanks for watching. Hopefully this was helpful in some way, entertaining in some way. If so, please hit the like button, subscribe for more videos. We'll see you on the next one.